to talk about preparing for LLMOps at enterprise scale. So this is something I'm quite passionate about in my role. And when I say LLMOps, and I'll explain this in a bit, I sort of mean all the foundation model related ops or anything to do with getting generative AI into production now. These are just some of the key themes I think about. I've trimmed down my presentation massively to try and get to 20 minutes just for a bit of a starter for 10, then we'll have a good conversation. I have tons of backup slides if you ask kind of good questions, so we'll see how we go. But just first, very quickly, introducing me. So I'm Andy McMahon. I'm head of MLOps at NatWest Group, which is one of the largest banks and financial groups in the UK. So we have 19 million customers, 1 in 4 business entities in the UK bank with us. So it's a big organization. And I lead the MLOps strategy and the MLOps Center of Excellence there. I'm also the author of the book Machine Learning Engineering with Python. 2nd edition was released late last year. And I've worked in lots of industries doing lots of fun things in data. So I've both been in the trenches and now kind of more in a more strategy focused role, but still quite hands-on. I've seen kind of all dimensions of the problem. And that's something that's really important for what we're going to talk about today, because I'm very kind of interested in how large organizations will adapt to the new wave of technologies that are coming down the line. So just getting straight into it. If you work in a large organization or even a smaller organization and you want to understand how we will build an enterprise-wide LLMOps capability, what should you be thinking about? Or what do I think about when I'm asked this question? Well, the first thing I think about is that generative AI is not a silver bullet. It's one piece of all of the tools that you sort of have at your disposal to make value with data. So many of us have been working in data science, MLOps, ML for a few years, and we understand that, it's a complex ecosystem we are part of. Even when machine learning came onto the scene, it was sometimes seen as a silver bullet. It would solve lots of problems. And it did solve lots of problems, but it won't solve all problems. And that's really important, I think, even as we move towards the more advanced capabilities that generative AI offers. It's just one piece of the puzzle. So we still have all of the infrastructure and platforms that we leverage across the data stack. We still have the more what I call classic machine learning solutions available to us. We have a general sort of data fabric, the data store, the data lakes, the lake houses, the access patterns for all of those. So I think that it's just important that we don't think, everything that's gone before should be thrown out. And the other thing that's important is related to that point. I view generative AI as very additive. So when we're bringing in large language models and other foundation models, I don't think we are throwing away all of the stuff that's been built over the past few years. I think we're just adding to that. We're building more capability on top of it. So it's important that we don't kind of, get given that the big budgets that we're getting or the big VC funding, and then we think, right, we'll get rid of everything we've learned from MLOps. We should think, let's build on top of that. I think that's the first important thing. The next thing I think that's really important is our teams will change. So as we adapt to leveraging these large models, and you could say they won't be large for very long, given everything we're seeing around, quantization work and the more effective sort of state space models, etc., that are developing. But let's assume they are large for now. Working with these models has some unique challenges that we need to cater for in terms of the teams that we build. So classically, we would have teams that may be focused on the right-hand side of the square. So we'd have data engineers bringing data from source into some target state, transforming it on the way or transforming it post-landing, and preparing it for use by downstream activities, including data scientists. The data scientists traditionally would build their own models, so they would be, analyzing that data, extracting features, building pipelines or functionality utilities that would build models based on that data and solve some sort of problem. And then we'd have the more engineering bent that came along a bit later, but in terms of MLOps and ML engineering, we'd have the people that would help within the team to build those data science models out into solutions or pipelines that could be productionized, orchestrated, and be part of wider architectures. And the MLOps engineer would really build out the platforms to help all of that go faster, in a nutshell. Now I think we're moving to a world where within the data functions in large organizations, we're now going to have software developers much more closely involved. So just to put some color on this, a lot of the organizations I know that have their own data and analytics function, NatWest included, it's kind of often quite separate from traditional software development. You still have a lot of engineering that has to go in, and you develop ML ops and ML engineering as a practice. But traditional full stack software development often sits quite separate. People over here are building the websites and the mobile apps, but people over here are building the back end ML pipelines. I think now, because a lot of these models have prompts as their interface, have natural language as the interface, it means we're often bringing those solutions much closer to the customer. So we're going straight from ML and working with the raw data through to a front end application much quicker. So software developers need to be run. And then we have this new role called the AI engineer. So to me, an AI engineer is really a software engineer that's comfortable working with machine learning models. So someone that maybe is more of a software dev, or even could be an ML engineer, but is now comfortable working with these large scale AI and ML models. As well as a question pop up, Amir, would you rather I did the questions at the end, or should we do them?
Let's get to them at the end.
Do them at the end. Cool. So I think the team will change. That's the first thing. So interestingly, I've not went with technology here. Technology is obviously changing. We'll talk about that as well. But I think people and process are going to change, and that's a big deal for large organizations. Right. Click. There we go. Another thing that will change, and this relates to the technology point, is we're going to have to change a bit how we adapt to the changing tooling landscape. So here it's a bit of a complex diagram, but I'll sort of explain each component. So at the top, we've basically got how we organize our people in terms of, you might have a centralized center of excellence that's responsible for curating best practice, patterns, providing templates and exemplars. And we find this a useful way of organizing ourselves in large organizations. And they filter out best practice to the teams that are more aligned to lines of business who deliver the value, deliver the products and solutions based on AI and ML. And they will all provide feedback to the teams running the core platforms, the core technology, and there'll be a kind of interaction there. And the bridge between the two is often the architecture teams or the architects working within the teams. The challenge now is that this platform is being extended. There's new things like vector databases, how we're thinking about prompt hubs. We're bringing sort of more application databases into the realm of data and analytics, where they definitely existed before, but they're becoming more of a concern now, I would say, with RAG-based applications, etc. And architecture teams have to be more nimble at translating between all of these worlds as things evolve much more quickly. So I'm already seeing, papers arguing that RAG is out the window because of large context window models. So RAG was just becoming the standard pattern, and now we need to adapt to a world where RAG may be one of the patterns, but there's many other ways of thinking about this. And that's quite a challenge for a large organization, especially one maybe or some organizations that are not used to moving at this pace. So that's going to be a big challenge as well. Good. And then the final thing, I think, and this will be where we get into some slightly more technical stuff, is I think we're going to have to adapt a lot of those practices we have adopted over the past few years. So I mentioned that I think everything's additive. I don't think we're throwing away MLOps. I don't think we're throwing away all the good platforms and tools we've developed. I'm not throwing away the best developer practices we've built up there, but we do have to adapt them. We have to change them in some way. And that's going to be really important, because that's how we will move at pace to deliver value in these large organizations, or any organization, but I think in particular large organizations that, again, don't change as quickly as smaller ones. So as an example, what I'm kind of going to go through now is how would you adapt your typical CI/CD processes, which should be a good part of your DevOps and then MLOps ways of working. How do you adapt that for working with generative AI? So here what I've done, and I'll show you the code in a second, is I've basically taken this excellent blog post down here from Llama Index in partnership with Tonic Validate. And what they've done is they've shown you how to adapt a CI/CD process to introduce a continuous testing component specifically for RAG systems. So this is leveraging a lot of external APIs, like the Tonic Validate API will almost always be using the OpenAI APIs in parts of our jobs, Hugging Face, etc. But it's kind of factoring it into a standard process that we should all be comfortable with if we've done CI/CD or DevOps or MLOps before, which is you do your software development, submit a pull request, it triggers some sort of action. Here I'm using GitHub Actions, but it could be, running on Jenkins, running on GitLab. It doesn't matter. It's whatever your CI/CD tooling is. That triggers some tests. And then if they pass the test, you successfully merge, and then you could deploy the code and you go around the cycle again. What you now have to think about is what's specifically different about generative AI or large language models. And the first difference is, as I said, calling out to those separate APIs. We were probably doing that before in some cases, but for a lot of tests that we were running in sort of classic MLOps, I would say we probably didn't have to do too many callouts. And this was very much the case in regulated industries. I know the previous talk was talking about another regulated industry, but in financial services, many of your environments are air-gapped. You try and not have them have general access to the internet for safety and security. So that means calling out to APIs is often a kind of a very particular consideration. You have to put the networking in place and make sure those accesses are available. You have to think about that. You have to think what sort of tests will you run. So what do you want to, actually test? What sort of metrics are changing? How do you know that this solution is being evaluated in the way you want it to? And that's all a bit different from kind of classic ML in terms of you're sometimes using another large language model to evaluate the large language model, etc. Good. Right. So what I'm going to do is actually just show you quickly some code. I realize we don't have tons of time, but it's interesting to see it in reality. So when you go through that tutorial I sort of pointed you to, and you'll get the slides later, or you can just Google it, tonic validate llama index. You'll get kind of instructions to set up a repo like this. So it's just setting up a basic fast API repository. So
is there a way to zoom in? Yep.
That a bit better.
Yeah, one more maybe. There you go.
There we go. Thank you. So the reason it says Oxford, I gave a lecture to Oxford last week. I used the same example. Sorry, you're getting the second-hand example, but it's a good one. It's a good one, I promise. So you set up this basic fast API app. So you can see just it's app, it's got an API, routers, chat, there's a chat interface. I'll go through that in a second. But it's very simple. The key thing we're going to do is we're going to build out some tests that use some of the techniques I was talking about. So if I first just quickly show you the main file of the app, you can see it's a very basic fast API interface. A lot of you have worked with fast API before. It's got some CORS, cross-origin resource sharing piece middleware in here. Key thing is it's got one root, API chat, and that takes us into here. And here what we've got is some basic Pydantic stuff to set up formatting and being strict about the format of the inputs and outputs. Same with kind of the interim data structures we want to use. And then the key piece here is that we've got a base chat engine, and the chat engine comes from Llama Index. So I'm using Llama Index here. And what we do is we basically provide a query and we get a response. And in the response, we get the role that the LLM is playing or the API is playing, the content. And then here what I've done is just to make things a bit more visible, added the context. It's a RAG-based system. There's also some indices that are generated through another script, which I won't run because sometimes it takes a bit of time, but these are stored here. So you can see it's just storing everything locally. So these are all the embedded vectors. Yeah. Cool. Now, if I very quickly run this, and I screwed up my Python paths in VS Code, that's why I had to run that thing. See, it's a basic app. So if I just send this, so what this RAG app is doing is it's actually using its reference data article by Paul Graham, who some of you might know. He's a Silicon Valley sort of commentator. So he writes lots of stuff about, venture capital, Silicon Valley, etc. So it's a very Silicon Valley flavored sort of RAG system. So here I'm just going to ask it, what's the most important thing about Silicon Valley? And it's going to hit that API. It's basically rooting out using this reference information, a classic RAG setup. And here it's provided me an answer. It's provided the context, so that's why the response is quite large. In production, you wouldn't probably share the context. Most important thing about Silicon Valley, according to text, is the people, Okay. Basic RAG system, nothing amazing so far. The key thing then is, like I said, you want to do CI/CD, you want to start testing this. So what we can do is we can use the basic PyTest framework. So I've created a folder called tests, and in it, I've created the test script. And in this test script, this is where I'm going to use this tool, Tonic Validate. So Tonic Validate, they have a platform online. I'll log into it and show you if we have time. They have an SDK. It's quite handy. It's not necessarily my favorite tool for doing this. There are tons of tools out there now that do the same thing, but it's just an interesting example of doing this. So they have a nice API where you can just supply some different metrics. Here there's RAG-based metrics around answer similarity, retrieval precision, etc. What you can do is just, here's some utility functions to call the solution. Here I've got some reference question and answer pairs. So I've made a small one just for things to run. So here, you know, leveraging those Paul Graham essays, what key components are necessary, key components are, here's a quote. But basically this will run that. This will run this final method, get all the answers, run some scores. Here's using the metrics. So it uses another LLM to do some of the comparisons. So answer similarity, for example, takes the answer and the reference solution uses an LLM and says how close are they to each other between 0 and 5, for example. Call the API, but the key bit is down here. I can just, like I would in a normal test in PyTest, put some conditions. So here I've asserted that the overall scores for answer similarity metric are greater than 0.5, and the overall scores for any other metric are greater than 0.5, as an example. And I can run this in here in PyTest. And you can see it's loaded the QA pairs for testing. Got 2 reference questions, so that was a smaller version. Maybe running super slow. Got an LLM response. Got responses, got 2 answers. And that then is going to take a while calculating the metrics. While that's doing that, I'm getting some errors, that's good. The classic curse of the demo. But while that's running that, what I'm going to show you is what I can then do. So that's just running PyTest. That'll pass or fail as it would normally, but imagine it's passing locally. I can then do the step of setting up my CI/CD. So I'm using GitHub Actions. So all I do is I go into .github/workflows, and in this YAML, Python app.yaml, I put some conditions. I'm just going to race through this. I'm not going to explain it in detail, but there's lots of stuff online about it. You can tell it, say, on push to the main branch or a pull request to the main branch, do these steps. And these steps are set up a Python environment to run this app, run the app, set up the vector index, and then run those tests. And here I've got some secrets for the different APIs that I use. There you go, 1 test passed and 4 warnings. 4 warnings, not too bad. And what I'll just finally show you before we maybe get close to finishing up is what that looks like in GitHub. So I won't again run this because it takes a bit of time. Here's one I ran before. So all I did was I committed a change locally. I pushed that into my main branch as a pull request. And then as part of that, this job is set up and it goes through all these steps, sets up the test server, tests with PyTest, etc., 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 and then completes the job. But you can see here what it's done is it's ran the app locally in this container and it's passed that test. So what we're doing is continuous integration, continuous testing, and eventually you can just push the app wherever you want it to in a target destination. And that's you doing continuous deployment as well for a RAG-based system. And that, I think, is an example of how we'll need to change some of our development practices for generative AI. I'm aware I'm nearly at time. I did have another section, which I will just give you the highlights of. I told you I'd do much. Yeah, Amir?
To go through that section quickly.
Yeah, I'll go through it super quickly. Sorry, I got videos in case things broke. So all I was going to do was talk about if you try and do something like RAG at enterprise scale, you've got those technical points, but you've got some other architecture design points as well. So there's a great article from Quantum Black, the AI company by McKinsey, how to build a knowledge assistant at scale. I'd really recommend you look at that. And they've got this architecture, sorry, it's so fuzzy, but they've broken it down into sort of 3 sections. So just quickly going through it in the last 30 seconds, you've got on the bottom left, the LLM section. So what they've done is they've broken out and said you should have a gateway that calls out to multiple LLM services. So they've been quite explicit saying Don't just sort of hedge your bets. Don't just say you're going to go with OpenAI API or go with AWS Bedrock. Even go for a series of different LLMs, and then you can pick and choose what you need for your use case. And when you start thinking about this at enterprise scale, you get all sorts of kind of questions that come up. So for me, I would think that, setting this up initially could be very costly rather than giving everyone just their API keys to go hit a certain API. I'm going to set up this new service and new kind of middleware that routes between all of them. More services might be more expensive. It might be harder for me to manage, but it provides a lot of benefits. So you're abstracting out that LLM component. You're going to provide a consistent access pattern. So no matter the back-end solution they use, you can provide a standard interface, GraphQL or REST API that you control. You can manage the interaction with that, rotating a JWT token, etc. You can also extend this as much as you want, and then you can pull out your usage and cost metrics from the one place. You can do other things as well. So they talk about the data layer. So I won't go through this, it's quite complex, but providing a data access layer, again, is a bit of a middle sort of path, a layer before you get access to the knowledge APIs you have. So maybe you've got wikis internally, organizational metadata. You'll have your vector stores for your RAG application. You'll have your core data lakes. You could have a knowledge graph semantic layer, anything you want. But again, it's fully extensible. You control the access pattern, but it makes this architecture, again, very flexible. And then the final component is the actual bit dealing with, once you have requests in the front end, how do you manage those prompt response sort of flows? And you can, again, use LangChain, etc. as an example. But when you get into that part, you start thinking, how do I standardize and apply guardrails that work across the whole organization? How do I create repositories and templates for really reusing the best prompts? And then how do I make sure that these workflows are being monitored effectively? And then how do I standardize them and make it as scalable as possible? And with that, I think I will just wrap up by saying there's lots to think about. I didn't talk about all these points like prompt engineering and prompt ops, but that's another consideration as well. But really, I think the key thing is that when you get to really large scale enterprises or larger applications you want to scale out, you have to just think, how can you add to what exists, and how can you build that out to really make it take on the new challenge of scaling out. And with that, I'll finish and open up to